Okay, hello everyone. So today we're going to be starting with this warm-up to get started. So put today's date. We have a proof that you're going to complete as best as you can. So we have these two triangles given on the right-hand side. We have some given information here, and we have a proof statement. So let's get started. We're going to make our statement and reason column. Okay, so the first given statement says that yx is congruent to ax. So remember what I said, for every single given information, you need to mark it and get a result. And the result for this one is that we have two equal sides. Okay, for the next given, we have line xz bisects angle yxa. So now you need to locate, where is yxa? Well, it is up in here. What happens when a line bisects an angle? Well, it cuts it into two congruent angles. So I need to name these two angles that I have there in red. Okay, so hopefully you're able to name them. That angle YXZ is congruent to angle AXZ. The reason is definition of a bisector. So right now we have a side and we have an angle. So thinking of those 5 methods, what else can I get now visually from the picture? Well, remember, we always have that common one where they're sharing a side. So they are sharing side XZ. So that's going to be our third piece of information in our proof. And that is called the reflexive property. And how now the triangle is congruent? Well, this is the sandwich one. This has to be SAS. So now I need to name the two triangles. And that is by side angle side. Now that I know the two triangles are congruent, now I could say that all the other stuff in the triangle is congruent. Specifically, the one that they're asking us to find is YZ and AZ. And the reason is CPCTC, because all the corresponding parts of congruent triangles are congruent. So on the next slide, it has the same thing that we just went through listed. If you need to pause it, you can. This is our objective for today. This is our last objective for this chapter 4.5. It is basically on angles and sides of an isosceles and also an equilateral triangle. We're going to have Math Excel 4.5 due next class. Next class, depending on when you have me, this week it will be a review day and a study guide, and then the tests will be next week when you come in to school. All right, so let's just talk about CPCTC. When do you use it? So it stands for corresponding parts of congruent triangles are congruent. You use this only when you need to prove a set of angles or sides equal in triangles. Most important thing here, and it's highlighted, very important, you must prove the triangles are congruent first by one of those 5 shortcut methods, and then you could get those pieces of information congruent. All right, so I do have another proof for you guys to try. Why don't you copy, pause this video, and come back to see if you're getting the correct answer. All right, so here's how I have it set up. Angle G is congruent to angle Q. That was given. They also are given O is the midpoint of side M to X. So what is the result of the midpoint? Well, it gives us two congruent segments, and I name those segments MO and OX. So right now, I have an angle and a side in this picture. I need to figure out what else I could get visually now because I used all my givens. So the only other thing I see are vertical angles. So I name the two vertical angles, angle GOM, angle QOX. That's by the definition of vertical angles. And now if you look at the position of the angles, so you have to be really careful. How is the two A's with the side there? Is it angle, angle, side, or is it angle, side, angle? It's definitely not this one because the side is not between the two angles, so it's AAS. And then finally, since I've gotten the two triangles congruent, now I can say in my last statement that angle M is equal to angle X by CPCTC. All right, so we're finally scanned to start our ELR 4.5. So in class, even though you're not going to be here, I'm going to ask each group to brainstorm and write down anything that they know about isosceles and equilateral triangles. You could go ahead if you'd like to do that, pause it, and then we're just going to get started. All right, so here's what an isosceles triangle looks like. I believe most of you understand that you do have two sides of a triangle in isosceles that are congruent, and these are specifically called legs. So this is a leg and this is a leg. Those are congruent sides. We do have two base angles here. These are also going to be congruent. And the top angle that's joining the legs up on the top is called the vertex angle. So we're going to be getting into two different theorems here on an isosceles triangle. So once you've copied this, then let's go to the two theorems. All right, the first theorem in this 4.5 section is basically what we just said on the triangle, that if I have two sides congruent in a triangle, here I have AC congruent to BC, then automatically I could say that the angles opposite of those two sides, so you need to locate them, and that would be angle A and angle B, they would also be congruent. Now I could also say the converse. Remember converse, where you're flipping the if and then statement? I could go back the other way and be given the two angles, base angles, congruent, A and B. Then I could say that the two sides are congruent also that are opposite them. So it's vice versa there. There also happens to be another theorem about an isosceles triangle. So take a look at this, copy this down. So if it says if a line bisects the vertex angle of an isosceles triangle, so that's what it's showing. We have this line, and it's bisecting this vertex angle up here. So that means it's going to cut it into two equal angles. Then this line, which mine here is black, is going to be perpendicular, making right angles. And it's also going to be a bisector of the base. So these two things are going to be equal there. Not only thinking of it's an isosceles triangle, these two are equal. And then obviously the two base angles are equal. So it makes two perfect right triangles from this theorem here. Okay, so let's find the value from this picture of x and y. Copy the picture. All right, well, I could get from previous knowledge that I know that this angle x is next to 110, so I know that adds up to 180, so this is 70. And it's looking like this is an isosceles triangle because I have two sides congruent, so that means these two angles on the bottom are both going to be 70. And then I also know what's happening about when a line is bisecting, right? This is that line that's bisecting up here, this vertex angle up here. Let's see what we get for that measurement. So if I take a look at this right triangle, it adds up to 180. 90 plus 70 is 160 out of the 180. So y is 20 degrees. And x was 70. All right, still moving on in this section is that equilateral triangle. One is the equilateral triangle theorem. So I'm assuming you all knew that the three sides are equal. So if I have all three sides of a triangle equal, then all those three angles are also going to be equal in degrees. And obviously, they're all 60 degrees going around. And then I could also do the converse of the equilateral triangle theorem. I could give you the three angles congruent, then the three sides would be equal. Okay, here's another question. If angle WVS is congruent to angle S, so WVS is right there, congruent to this one here, is segment TR, this one here, congruent to TS? All right, so this is dealing with the converse of the isosceles triangle theorem. So if you notice, they're telling us given that this angle is equal to S, and now we also have this random angle over here that also has a tick mark, is also equal to that S also. So if you notice, R and S are base angles. They are equal. So then that means these two sides have to be congruent by the converse, right? By the converse of the isosceles triangle theorem. So that makes, yep, TR. So TR is congruent to TS. All right, moving on. Slide 14, here's another example to try. Well, I already know by the isosceles triangle theorem, because AB is equal to BC, I know A and C are going to be 54 degrees. And I also know by that other theorem that I just learned that if a line is bisecting the vertex angle, and it is, if you notice with the tick marks, that makes this 90 degrees. And then I could get that angle up there by adding them up and subtracting from 180. So x is going to be 36 degrees. All right, for this last example here, there you go. Try to get your answer for x and y here. Okay, well, how I'm going to start this one is that I know that x is lying on a straight line with 125. That's a linear pair. They are supplementary. So I could take that away from 180. I have 55 degrees here. Then I know vertically this is also 55 degrees. And now basically I could get my y angle because I know now that this angle here is going to be equal to this angle here by the isosceles triangle theorem. Okay, so I get 125 degrees left, but then there are two base angles, so they're equal, so I'm going to divide them in half. So the y angle is 62.5 degrees. All right, so that's it for ELR 4.5. So today we quickly talked about angles and sides of isosceles and equilateral triangles. Please do that Math Excel for practice and use the Help Me Solve This button if you're having trouble. Next class will be review and working on the study guide. There are office hours Tuesday after school if you plan on coming. And then our test next week will be that Monday, Tuesday of the following week.